Hello guys, welcome to Tech Rabbit. Today we will learn how to code SVM using Numpy. In a last video, I explained what are the basics of SVM. Uh, so we will code this SVM algorithm using Numpy. So let's start. As you know, SVM is basically like using a hyperplane, choosing a best hyperplane which gives highest margin. Okay, so there are multiple hyperplanes we can define, but the base hyperplane is we will select is which having a maximum margin. So out of these three we will select the one which having a higher margin. So this is the one. Okay, you see this hyperplane having a maximum margin, and this is the decision boundary, and these are the support vectors where the lines intersect the points. We will call as the support vectors. Okay, so let's start coding. So first we will run using a numpy. We will import numpy and matplotlib for visualization. We will take input array for 5 by 5 by 2 5 by 3. Actually we need to add 1 as a bias. So you can see it here, in every sample point I added a bias point. uh, so actually my points are -2 and 4, 4 1 1 6 2 4 and 6 2. And output, that is I categorized into two category, like -1 and 1, that is -1 -1 1 1 1, means first 2 points are negative and other 3 points are positive. So if you make a plot, so this will look like this. So this is the code for plotting these points. Okay, so this is the plot. If you these are the negative points. Okay, -2 and 4, 4 and 1, -2 4 4 1, and these are the two negative points. Okay, and the rest three are positive points. So this is how I plotted, and I randomly took a hyperplane by using this formula. This is the blue line, which 6 by 6, for just for the reference to understand. In next step we will define this also hyperplane. So misclassification condition. These conditions I have attached here just for the reference. You can see this is the weights and learning. This is a eta is a learning rate, y is the output, x is the input, -2 times of lambda into weight. Okay, so here lambda is the epoch. I will this once we will understand this code, we will go through this formula. Okay, so this is the definition I defined for getting output as weight and output. Okay, so we will pass input and output vector. So first we will initialize the weights with the help of by the size of x. Okay, learning rate as a 1, epoch as a 10,000, and we will pass we will run this loop. Okay, we will run this loop for the 10,000 times, and this is a function. This is actually for loop where uh, uh, we are using enumerate. In this enumerate will assign the value of x to val and its index to I. Okay, so this is the code. We will take val1 equal to dot product of x and weight, and we will this is actually a main formula where we differentiate the two category. So if the dot product is less than 1, we will use this formula to update weight, and if it is greater than 1, we will use this formula to update the weights. Okay, this formula is equal to like a weight plus learning rate into dot product of output and input -2 times of 1 upon epoch into weight. Okay, and if the value is greater than 1, we will simply remove this term and multiply the rest of the things. Okay, this is how we will update the weight, and this will run 10,000 times, and the final weight will be uh, uh, we will take it out. Okay, now next we will take the what is the output answer. Okay, same we will run this enumerate loop, and we will get the output. Okay, here I am I am calling this function and assigning the output of this function into w and out, and I am printing these values. And once you print the value, you will get to know that this is weight, okay, W1, W2, and you remember we assigned for uh, one for each sample points, so that is the bias. So it means first two values are weight and third value is a bias. Okay, so 1, 3 and -10. So okay, and the predicted value is -1.5, -1.5, 8.9, 4.4, 4.5. Don't look at the actual value, just look at the negative sign or positive sign. So this will we can differentiate. So first two values are negative. uh, that is what we have predicted initially, and rest two values are positive. Okay, rest values are positive. Yes, this is how we train our model. Now let's test this one on the actual two different samples. We are taking -1 1 and 5 and 5. By definition it should be a first value should be in the negative side, and 5 by 5 will come here, that is on the positive side. So this is by definition it should like this. Let's see the result, what will the output. Okay, we will run this code, and yeah, so the output will be like this. First is negative and second is positive. So -1 3 is in negative side here, and 5 by 5 it is on the positive side. So this clearly differentiate our with the help of Apple Pen we have differentiated two categories. So this is all about SVM using a NumPy. So yeah, in the next video I will explain you how to code using the sklearn library. uh, okay, thank you guys.